Hello everyone, welcome back. It's good to see you. Today's lesson is Unit 9, Part 2. We are going to talk about standard deviation and normal distributions. Remember last week we talked about probability. It was a part of our probability and statistics unit, and now we are moving on to the statistics part. So we have two objectives today, talking about standard deviation and normal distributions. Your assignments for this week. Same as usual. It's actually a little bit shorter though this week. So you have a 20-point classwork assignment. It's based off this lecture, 10-question fill in the blank. And then you have only two Khan Academy objectives, and they're based off the two objectives from this lecture. So this video, as you can see below, is a lot shorter than usual. But that's just how it worked out this week. If you are a senior, you're finished. Why are you watching this video? Log off and celebrate, right? Nice work to those seniors. And I hope that you're able to enjoy this period, these few weeks before everybody else ends the year. All right, so moving forward, today's objectives, we are going to do a couple of things. First, we are going to use standard deviation as a measure to describe data. We are going to calculate standard deviation of various data sets, and then we are going to use our understanding of standard deviation and mean, or the average, to describe and analyze normal distributions of data. I know that it seems like a lot, and there's some new words in there, / terms, standard deviation, normal distributions. Don't be overwhelmed. It should be relatively straightforward once we go through the process. Objective 1, we are going to calculate standard deviation. First of all, you may have heard this term before, but we definitely have not used it in Algebra 2 yet, so we got to define it. Standard deviation is a measure of how spread out your data is, okay? So if it is really spread out, you have really low values and you have really high values, then your data set, your collection of data, would be said to have a high standard deviation. Now, if all of your values are concentrated about the mean, about the average, if they're all really, really tightly packed close together, that is a situation where you would have a low standard deviation because it's not spread out. So again, standard deviation is a measure of how spread out your data is. It has a numerical value, and we're going to be calculating that numerical value as our first objective for today. But because probability and statistics is set in the real world all the time, here are some real-life examples of standard deviation. Let's say you're comparing the ages of people at a football game versus the ages of people in a kindergarten class. If I asked you which has the higher standard deviation, you would tell me the ages of the people in the football game. Why is this? Because at a football game, you have young kids there, as well as you have old people there enjoying the game, and everybody in between, right? Teenagers, young adults, middle-aged, whatever it may be. You have a high standard deviation of people. However, in a kindergarten class, you've got 5-year-olds and you got 6-year-olds, right? That is a low standard deviation because the ages are concentrated, they're tightly packed together. Another example, let's say that you go shopping and you're looking at prices in various stores. Comparing the prices of a Guitar Center, one of my favorite stores, and a Dollar Tree, all right, which has the higher standard deviation? Well, sometimes I go into Guitar Center and I just buy a pack of strings for my guitar, or even cheaper, I buy a pack of picks, guitar picks, because I run out. That costs a couple of bucks. On the other hand, you could go in there and buy an electric guitar, or you could buy a piano, or you could buy a drum set, and you could spend thousands of dollars, right? So you've got things that you can buy at Guitar Center for a couple bucks, and you've got things at Guitar Center that you can spend thousands of dollars on. That is a high standard deviation because the data is spread out. Compare that to the Dollar Tree, depending on what type of dollar store it is. Some of those Dollar Trees, right, they have literally all the same price. They're all $1. It's a dollar store. So that would be a case where you have a very low standard deviation. In fact, if every single item cost $0, cost $1, if every single item cost the same exact thing, it would actually have a standard deviation of 0 because the data is just one price. hopefully that gives you a little bit of understanding of what standard deviation is. Along with standard deviation, we are going to be talking about mean. This is not Algebra 2 material. We've talked about it a lot before, but just as a quick review, make sure you remember how to calculate mean, which is, again, the average of a data set. If you want to find the average value of a set of data points, you simply add up all the data, and then you divide by the number of data points that you have, right? So if you have 10 test scores and you're trying to find the average score on that test, you add up all the scores and then you divide by 10. You will need to calculate the mean for pretty much all of the problems in that first Khan Academy objective, all right? But that's not that tough to do. Make sure you use a calculator. So the first objective where we're calculating standard deviation, we are going to be using this equation here. However, we are not going to just plug in numbers for variables like we typically do, because this equation is a little bit strange. But I do want to show you the equation of where our work is going to be coming from today. So if you want to find the standard deviation is equal to the square root of sigma of your value minus your mean squared over n being your number of data points. A couple of things about this. SD, I couldn't find, this is what was on Khan Academy. I'm going to be using a symbol called sigma today. You've probably seen this before, but sigma is the symbol that is used to represent standard deviation. I'll show you what that looks like in our first example. X right here refers to a value, a data value, and you're going to have several in your problem. And then this symbol right here is called mu. It's pronounced Mew, like the Pokemon. I think there's a Pokemon named Mew, or Mewtwo. That represents your mean, okay? So whatever your mean value, we represent that through mu, and you spell that mu. And then divided by n is your number of data points. We already said that. Moving forward, instead of the equation, what I would really like you to focus on in regards to the questions that we'll be doing shortly, when you're calculating standard deviation for a data set, use these steps. I try to break down, make it simple for you. It's basically the equation, but we're following these steps instead. So if you have a data set, if you have a list of numbers, and you're trying to find the standard deviation, these are the things you got to do. Step number one, you got to find the mean of the data. Sometimes it'll be given to you, a lot of the times it will not. Number two, you create a 2-column table. You're going to list your data points on the left-hand side in your first column. Just list the numbers that you have. It's helpful to do at least to greatest, but you don't need to. Step three, in column 2, you're going to subtract the mean from each value, and then you're going to square whatever you get. So please realize that in column 2, since you're squaring that difference, in column 2, every single number should be positive. If you see any negative numbers, you did something wrong. Once you get all the numbers in column 2, it's the difference between the mean and the value squared. You're going to add up all the numbers in the second column, and then you're going to divide by n. In other words, you're going to, step 4, average the numbers in the second column. And then finally, step 5 is whatever number you had for that average of the numbers in the second column. Step 5 is you square root that. And the square root of that value is your standard deviation, or sigma. And that's where you end the problem for this first objective. All right, so we are ready for examples since we have those steps. We're going to utilize those steps for 2 data sets. They are very close to what you'll see on Khan Academy, so make sure you're taking good notes. All right. Example number 1. And I'm just going to get these steps out because I'm going to be looking at this every once in a while. All right. So here it says, find the standard deviation, and we have a list of points. All right. So 0, 1, 1, 1, 2, 2, 4, and 5. Step number 1 is we need to find the average. So I'm going to label this. Oops. Step 1, is we got to calculate what mu is equal to. How do we do this? Well, we take the sum of all of our data and we divide it by n, or the number of data points. Use your calculator if you want, but I would suggest doing this in your head, right? We have 1 plus 1 plus 1 is 3, plus 2 is 5, plus 2 is 7, plus 4 is 11, plus 5 is 16. Let me do that again in my head to make sure I get that right. Yep, our sum of these 8 numbers is 16. And then how many total numbers do I have? 1, 2, 3, 4, 5, 6, 7, 8. What is 16 divided by 8? It's 2. So that means the average value of these 8 numbers is 2. Great. Moving on to step 2. Let me look at my list here. Step 2 says create a 2-column table, and you are going to list your data points in the first column. All right. So I am going to do that in a different color, orange. And I'm wondering if this is going to be big enough. I think I might create a new page here, just so I don't have to cram it in. All right, so step number 2, I'm going to create my list of values. It's a 2-column table. In the first column, I'm listing those values. So I have, let's see here, 0, 1, 1, 1. So my first column, 0, 1, 1, 1. Oops. 2, 2, 4, 5. 2, 2, 4, 5. All right. And then step number 3, we're done with step 2. It says in the second column, subtract the mean from each value and then square that value. In other words, what we are going to do is we are going to take x, we are going to subtract mu, and then we are going to square whatever we get. What was our mu value again? Mu was 2. That was our average of our 8 points. So I'm actually going to plug that in right here at the top of my column header. So over here we need to do x minus 2 squared in the second column. Okay, this doesn't seem that hard. You can use a calculator, but I'm just going to say this out loud / do it in my head. For the first row, 0 minus 2 squared is going to be 4. 1 minus 2 squared is going to be 1. 1 minus 2 squared is going to be 1. 1 minus 2 squared is going to be 1. 2 minus 2 squared. 2 minus 2 is 0. 0 squared is still 0. Cool. For 4, 4 minus 2 is 2. 2 squared is 4. And then finally, 5 minus 2 is 3. 3 squared is 9. So those are the numbers that I have in my second column, and now step 3 is done. Remember what I said when I was introducing those steps for the first time in step 3? Your second column, all of these numbers, all of them should be positive because you're subtracting x minus 2, and even if you get a negative number, you square it afterwards. So anything squared becomes a positive number, except an imaginary, but we're not talking about those right now. All right, so step number 4, if you return to your notes, it said average the numbers in the second column. So we are going to add up all of these guys, and we're going to divide by 8. And that'll be our average for step 4. All right, so 4 plus 1 is 5, plus 1 is 6, plus 1 is 7, plus 4 is 11, plus 9 is 20. So my step 4 average is going to be 20 divided by 8. I added up all the numbers in the second column, and now I'm dividing by the number of points I have. 20 divided by 8 is equal to, I'm going to get a decimal here, I'm going to keep it as a decimal, 2.5. And then finally, step 5, square root this number, square root the 2.5, and you end up with your standard deviation. Plug that into your calculator. The square root of 2.5 is equal to 1.58. 1.58114 in my calculator. We're going to knock that off at 2 decimal places. And this is the answer to our first standard deviation problem. Our standard deviation is equal to 1.58. Remember that this is a numerical measure of how spread out your data is. One final thing. Remember that when we express our answer, we typically want to use the correct mathematical symbol. I said that standard deviation is usually represented through the symbol sigma. And the way that you write this is like this. So that says sigma is equal to 1.58, meaning the standard deviation is 1.58. Moving forward. Find the standard deviation of these test scores. All right, so we have 85, 100, 92, 96, 87, 94, 75. We have to calculate how spread out this data is, get a measure of the standard deviation. We are going to utilize the same exact steps as before. All right, so first of all, let me list my numbers, and they're all jumbled up right now. I'm jumping ahead of myself. First, find the mean of the data. So I definitely have to use my calculator for this. We are going to take the sum. So I'm going to add up all of these numbers in my calculator first. 85 plus 100 plus 92 plus 96 plus 87 plus 94 plus 75. Double check it in my calculator, make sure I didn't screw anything up. Cool. I got 629. Divided by, okay, so we have how many data points? 1, 2, 3, 4, 5, 6, 7. 7 data points. 629 divided by 7 in my calculator. What does it come out to? Darn, a decimal. That's unfortunate. 89.86. All right. So now we list our values, and I am going to do this on a new page again. That didn't work. Nope. Right here. There we go. All right. So I'm going to list my values in this table. We have, I'm going to try to do this in order. Lowest test score is 75, 85, 87. 75, 85, 87. 92, 94, 96. 92, 94, 96, and then we have that 100. Cool. So sometimes it's helpful to actually write out the whole expression in the actual table before we just like put the answer. That's what I'm going to be doing since this is a little bit more complicated. Remember that our mean for this problem, we got a decimal, right? So I'm going to plug that decimal in right now. We got 89.86. So we're going to take each x value, we're going to subtract 89.86, and then we are going to square it. In the first column, I do 75 minus 89.86. Press enter, I get negative 14.86. And then I have to square that negative 14.86. And I get 220.82. That's in my first row. In my second row, I'm going to do the same thing with 85. First of all, do 85 minus 89.96, our mean. And we get negative 4.96. We have to square that, and we get 24.60. I'm not going to write this all out for you, but I just wanted to show you these first two rows so you can see the step-by-step of how I'm getting that answer in each row. All right, we take the number, subtract the mean, and then we square it. So moving forward, I'm going to go a little bit quicker, and I'm going to fill out the rest of this table. You can pause the video if you want at this point, and try to fill out the rest of the data on your own before checking it with me. I'd recommend you do that. And I accidentally wrote 0.96 here, I realized. I'm going to fix that error real quick. Okay, so this should be, I'm sorry about that. This should be negative 4.86. And negative 4.86 squared is 23.62. Sorry about that. All right, so now on to the rest of the table. And I'll try to make this quick for you guys. So we got 8.18. We got 4.57. 94. We've got 17.14. 96 squared is 37.70. And then finally 100. Square it and we get 102.82. So I took my value, subtracted the mean, and squared it for all 8 rows in my table. Now I have to find the average of those values. So I add up all of the numbers in the second column, 220.82 plus 23.62 plus 8.18 plus 4.57 plus 17.14 plus 37.7 plus 102.82. Just double checking my calculator that I didn't miss anything. Cool, cool. I get 414.85. And then I'm trying to find the average, so I divide that sum by the number of points, which is 7 in this problem. And I get 59.26. My final step to find sigma is I square root that answer. And I get a standard deviation when I square root 59.26 of 7.70. This is what sigma is equal to for this problem. Process was the same, but if you have a mean that is a decimal, it's obviously going to be a little bit tougher, and you're going to have to utilize your calculator even more in a situation like this. Well, we finished. Standard deviation is 7.70. Try out those problems on Khan Academy. Objective 1, where you're calculating standard deviation, they are very, very similar to what you just saw over these last 2 examples. Moving forward, we got one more objective to do. It's up there, and you can't see my face. All right, so moving forward, objective 2. We are going to utilize the empirical rule for normal distributions. You have not heard of normal distributions, and you have not heard of the empirical rule, so I've got to do some explaining at the beginning here as well. First of all, normal distributions, what are they? Well, they are bell curves, in other words. It is a probability distribution that is organized in a bell curve fashion, where you have the highest point at the center, and then it tapers off at the ends. You can see a picture right in front of you on this slide. A bell curve is symmetric about the mean. So the mean is in the center of this bell curve that represents a probability distribution, and it's symmetric. It's the same on the right and the left side of the mean. In a normal distribution, most of the data is concentrated around the mean, all right? And then less data exists the farther away you get from the mean. And this is called a normal distribution because a lot of the time in life, in the real world, data is organized in this way. If you have data, and I don't care what you're talking about, if you're talking about heights or weights, or if you're talking about IQ scores or test scores, or if you're talking about income, if you're talking about populations of cities, or it can be anything, any numerical data. A lot of the time it's organized in this way, organized as a normal distribution. An example, in real life, this is true, all right? Heights of American adults would follow roughly a normal distribution. It's not going to be a perfect bell curve, but often we can approximate real life situations as a normal distribution. What do I mean by this? American adults, their heights. Okay, so this graph right here, actually going to make this a little bit bigger for you so you can see it better. This represents a normal distribution of American adults' heights in inches, all right? What is the mean height of an American adult? It's whatever value is right here in the center of your bell curve, which if I go down, it looks like my mean height is 64 inches. 64 inches. Divide that by 12. That's 5 foot 4 inches. I don't know about that, but let's pretend this is a real thing, all right? So your mean is 64 inches, and then you can see on the right and the left side, it's symmetric. So this means that most people are around 64 inches tall. However, as you know from experience, right, not everybody is average height. Sometimes you get really, really tall people, like 70 or 75 inches or even 80 inches. But you can see, if the line represents the frequency of the data, that the farther you get away from the mean of 64 inches, the lower and lower your chances are of being that height. Same goes for farther away from the mean on the left side, so less than your mean, shorter than usual, right? A lot of people are 64 inches the mean, right? But as you get away to 63, 62, 61, 60, less and less people are those heights until you get to the really low below the mean, like the 55 or the 50 inches, and there's hardly any adults that height. So the normal distribution, again, it's a symmetric bell curve. Most of your data is in the middle, near the mean, and then the farther you get away from the mean, the less data you have. And this, again, normal distributions pop up all the time when you're talking about random data. Think about temperatures in Florida during the month of May, during our current month. Or let's do April, since we're done with April, right? You had an average temperature in April of 70, 80, something in that range, where most of the days it was in that 70 to 80 range. But then occasionally you would have a really, really cold day, right? Where it'd be in the 50s or even no, not the 40s, but maybe the 50s. But that only happens once or twice. And then sometimes, I know in April, it was really, really hot, like upper 90s, right? But it didn't happen that often. Most of the data is concentrated in the 75-degree mean area, and then less of the data exists the farther you get away from the mean. Let's move forward. Another example, ACT scores. This is more relevant for you here, and these are actual numbers that I'm not making up, all right? So the mean ACT score, don't know what year this is from, but it has to be sometime within the last 10 years, I would think, is 20.8. So that's the average ACT score. And then that sigma right there represents the standard deviation. So that represents how spread out the data is. A lot of people score in that middle range between 16 and 25.6. But then as you go farther away from that average score, you still have people scoring those scores, but they score them a lot less, right? So if you're looking at a score of 31 or a score of 35, I think a perfect score is 36, right? You can see that that curve slopes down because not a ton of people are scoring that high on the ACT, as well as if you go in the opposite direction, right? The height of the curve is really, really low right here at 6.4 or 11.2 because not a lot of people are scoring that low. Most people score in the middle. That's a normal distribution. Now you should be asking why. Like, okay, I understand that. It's nice that it has a name, but I kind of already knew that, right? That most of the time data exists near the mean. The reason that this is so cool is that we can look at distributions of normal data and we can actually approximate the percentages that fall between certain values or fall above a value or below a value. And to do this, we use something called the empirical rule for normal distributions. You have to know these percentages that I'm about to go over, all right? The empirical rule states that for a normal distribution, 68% of your data falls between one standard deviation of the mean. 95% of your data, almost all of it, falls between two standard deviations of the mean. And then 99.7% of the data falls between three standard deviations of the mean. 99.7% of the data is almost 100%, right? You only have 0.3% on the ends. Anything that is beyond three standard deviations to the right or to the left of your data, that is considered an outlier. And that is an answer to one of your classwork problems. So this can be summed up, this empirical rule, on the next two slides. I give you a basic view and a detailed view. If your data is a normal distribution or can it be approximated as such, this is the basic empirical rule. 68% of your data falls between one standard deviation from your mean. 95% of your data falls between two standard deviations from your mean. And then 99.7, roughly all of it, you just have a tiny little bit on the ends, fall between three standard deviations of the mean. Again, anything beyond three standard deviations is considered vocab term an outlier. A more detailed view, and yes, you should copy this down. This shows the same exact percentages, it just breaks it down a little bit more. You can see that 34 plus 34 is equal to 68, right? So 68% of the data falls between one standard deviation of the mean still. But what this does is it says, okay, half of that is 34, right? So the percentage of data that falls between the mean and plus one standard deviation is 34%. And what we're going to be doing is we're going to be using primarily this diagram to answer some real life questions about IQ scores. So we're going to ask like what percentage of people have an IQ between 100 and 135, or what percentage of people have an IQ that is lower than 85. Whatever it may be, we are going to use diagrams like this. We're going to be adding up percentages in this diagram to find those percentages. Returning to the ACT example, if I asked you what percentage of people scored between a 16 and a 25.6 on the ACT, Well, you would say, okay, 16 and 25.6, that's one standard deviation from the mean. That means that 68% of people scored between a 16 and a 25.6 on the ACT. 95% of people scored between 11.2 and a 30.4, and 99.7% of people scored between a 6.4 and a 35.2. Yeah, there's some outliers. There's some people that scored 5 or below, and there's people who scored perfect scores at 36. But they're, one in a million, once out of, thousands of students taking it. All right, so ready for examples. In these problems, we're going to get real-life situations that can be modeled through a normal distribution, and we are going to actually be drawing the curves, labeling the curves according to their mean and standard deviation, and then answering 3 questions. This is one example, but it has 3 parts. And then you're done, and you're ready to move on to asking questions, classwork, homework, that sort of thing. Here's your example. Please make sure you understand this and write down the mean and standard deviation. IQ scores, a measure of intelligence that who knows how actually valuable an IQ score is, but people still use it. IQ scores follow a normal distribution with a mean of 100. The average IQ score is 100. This is true. I'm not making this up. And the standard deviation is 15 for an IQ test. Again, these are actual numbers. Use the empirical rule to answer the questions below. And we have a couple of questions. For a random person, what is the probability that they have an IQ higher than 145? What is the probability that a person has an IQ lower than 115? And what percentage of people have an IQ between 85 and 115? We're going to answer those 3 questions right now. All right, so this is all the information that you need up here. We have an average IQ score of 100 and a standard deviation of 15. And what we're going to do right now is we are going to create our normal distribution curve for this situation. I am going to draw that bell curve. And I'm going to use the entire screen. It's not perfect, but it's close enough. I'm going to draw a line straight through the middle, and this is going to represent my mean. I'm going to label it with a little m or a mu symbol on top, and then I'm going to put the actual value of the mean on bottom. The actual value of the mean is 100. And now it's really important that you label this normal distribution with 3 standard deviations to the right and 3 standard deviations to the left. So we're going to draw 3 lines to the right. They should be evenly spaced. And 3 standard deviation lines to the left. They should be evenly spaced. And we're going to actually label them. So this is +1 standard deviation from the mean. This is +2 standard deviations from the mean. And this is +3 standard deviations from the mean. Then over here we have -1 standard deviation from the mean, -2 standard deviation, -3 standard deviation. And then on the bottom, we are going to actually label it with its specific test score, IQ score value. So this line right here is 1 standard deviation above the mean. So our standard deviation is 15. So 15 above the mean would be 100 plus 15. We're going to label this with a 115. And then you just have to add another 15 to get to the next line. 115 plus 15 is 130. 130 plus 15 is 145. The distance between the lines is always equal to your standard deviation, which in this example is 15. But it will be different for the problems that you do. It'll be different for every problem. Okay, so going down, Your standard deviation is 15. So 100 minus 15 is 85. 85 minus 15 is 70. 70 minus 15 is 55. And now we have completely labeled our, Now we've completely labeled our normal distribution, except for the percentages. And that's what I want to do right now. We're going to go back to this slide, which you should have in your notes, this one, and we're going to actually write those percentages in. So on the very ends, we have 0.15. Actually, let's start in the middle, 34%. I'm sorry, I lost myself. I have so many tabs open right now. Where am I? Okay. Let me do this in another color. We're just using the same percentages. This is always true. And I don't have these percentages memorized, so I actually have to look at the notes with you guys. 13.5% to the left and right of the 34s. Then we have 2.35%. And then at the very ends, beyond 3 standard deviations from the mean, will be 0.15% of your data. It seems like a lot of work, but now that you have those percentages and you have your normal distribution labeled, the answers to A, B, and C actually become very easy to do. So let's walk through each part. Part A. It says, what is the probability that a person has an IQ higher than 145? So what we do is we go to 145 and we look at the percents that are higher. In this example, it would just be this 0.15%, right? What percent is higher than a 145? 0.15%. That's it. Moving on to part B. Part B asks, what is the probability that a person has an IQ lower than 115? Okay, so I'm going to do this in a different highlighted color. We'll pick green. Our question was, what is the probability that someone takes the test and they have an IQ lower than 115? So I'm going to highlight 115, and then I'm going to actually look at all of the percentages that are below 115. So that would include this 34, this 13.5, this 2.35, and this 0.15. And what do you think I have to do with all those percentages? They're all below 115. So if I add them together in my calculator, that's what I'm going to do to find the probability or the percentage of people who score lower than a 115. It will be over 50%, right? Because your average is 100. So the percentage of people who score below a 115 is equal to 34 plus 34 plus 13.5 plus 2.35 plus 0.15. Or in other words, 84%. Finally, part C. What percentage of people have an IQ between 85 and 115? I'm going to highlight 85 and 115. 85 right here, 115 right here. And now I'm looking for the percentage of people between those two scores, right? 85 is right here, 115 is right here. What percentages exist between those two test scores? We have 34 and we have 34. Add 34 plus 34 together, and that means that 68% of people have an IQ between 85 and 115. And we should know this from the empirical rule, that's 68, 95, 99.7, because 85 and 115, that's between one standard deviation from the mean. So we end up with that 68%. Thanks so much for sticking with me through this presentation. If you have any questions whatsoever over the course of the week, please reach out to me in Teams or reach out to me through email, and I can answer your questions anytime from 8 to 2:30. Our daily video chats are at 10:15, 11:45, and 1:45. Log on at those times to see actual walkthroughs of problems that you're struggling with. If you have any troubles whatsoever, I'm here to help. Hope you guys have a good week, and I'll talk with you later.